Hey guys, welcome back to another one of these A-level mastery videos. So today I saw a question on logarithms, which is pretty tricky, 7 marks, it's not that bad, but it does include a skill that is really important if you want to get a decent grade at A-level maths, so namely A's and A stars, which is something called substitution, okay? So you're not going to be able to solve every single equation at face value. So I wouldn't know how to solve this equation without doing a substitution. Okay, and this comes up with trigonometric ratios, it comes up with integration and differentiation too. It comes up with a hell of a lot of stuff. And some of the hardest questions will involve you having to do substitution, but it's actually not as bad as you might think. So let me show you what I mean. So if we start with this question here, well, the first thing I notice is I can move this 2 here to the front by using the power rule. So that's going to be 2 log 4 x over 5 plus 2 log 4x plus, I'm going to keep that in brackets because remember, this, when it's in brackets, is not the same as this. These two things are not equal. This is log 4 of x squared, so the log is of x squared, where this is log 4 of x all squared. So this, you're taking the log of x first, then squaring it. This one, you're taking the log of the square of x already. Now, you might not be able to see too much from here in terms of like what you need to do, but I'm hoping what you can kind of see is this actually looks a bit like a quadratic. So, if you look, we have a squared term, right? So that's where the quadratic comes from. And then we have 2 linear terms. So if I just substitute in y equals log to the base 4x, look what happens. So we have 2y over 5 plus 2y plus y squared. That is just a quadratic equation which we can solve. You guys know how to solve these. So how do we solve it? Well, we want to get rid of the fraction first, so I'm going to times through by 5 plus 2y. And just to go back to that kind of point about substitution, it is vitally important that you can kind of notice these things. Now, I could have done something slightly different to make it maybe a bit more obvious in terms of timesing both sides by this first to get rid of the fraction, but I think it can get harder to spot in some cases. So we have 2y plus y squared 5 plus 2y equals 0. You could factorize out a y here, by the way. Factorize out a y and then add everything up. But I'm not going to do that. I'm going to expand first and then factorize just to make sure we're all on the same page. Because I don't want to get into something that's too advanced. That is a cubic equation. However, I can factorize out a y. And what I'm going to do is I'm actually going to write the 2y bit first. So the cube term first. So 2y squared plus 5y plus 2 equals 0. From here, we have 2 solutions. Well, not 2 solutions, sorry, but we have a few different solutions. So I could factorize this to get another value, or you can just use your calculator to work out the value. So I've shown you a couple times how to work out the answers to quadratics. So if you look, this is just a quadratic that we can solve using a calculator, but if you didn't know to do that, you could just factorize, and that would give you 2y plus 1 and y plus 2 equals 0. So now we have 3 separate solutions. We have y is equal to 0. We have y is equal to, well, if we move this around, we're going to get 2y plus 1 equals 0. So 2y plus 1 equals 0. So 2y equals minus 1. So y is equal to negative a half. And lastly, we have y is equal to negative 2. But those aren't our answers because remember, we're trying to solve for x. So we're trying to solve this. So now we have log base 4x, log 4 of x somehow equals 0. We have log base 4 of x equals negative a half. And log base 4 of x equals negative 2. And if you remember what this is actually saying, and this is the really important bit, is if we use the definition of a log, you can rewrite this as x equals 4 to the power of 0. So all you're doing is you're basically doing the inverse of a log on each side. So I call it raising to the power. So you're doing 4 to the power of log 4x equals 4 to the power of 0. But if you remember, powers and logs are actually opposites to each other. They're inverses, so that goes away and you're just left with you're just left with that. And what's that? Well, that's going to be equal to 1. Using the same thing, we're going to have x is equal to 4 to the power of minus a half. So that's 1 over the square root of 4. So that's 1 over 2. Technically, it would be plus minus unless it says otherwise. And then lastly, but certainly not least, we have 4 to the minus 2, which is 1 over 16. And those are actually our 3 solutions. If you look, this is a 7-mark question. Realistically, it's not that long, but knowing to actually do a substitution can be a bit tricky because some students don't really know to do that, which is fine, but I just wanted to make you aware of that because, again, substitution comes up a hell of a lot in year 13 as well. So, enjoy your evenings.